Hello students, and welcome to another video. I'm your teacher, Mr. Flynn. Today we're going to be talking about radioactive decay chains. We're going to spend most of our time looking at this chart down below, okay, and we're going to be examining how thorium decays over time into something more stable like lead. Okay, and this process takes about 11 years, and there's going to be a variety of alpha and beta minus decays. And if you remember from our previous videos, I've talked about these radioactive processes. Alpha particles are basically helium atoms. So they're losing 2 protons and 2 neutrons. And then we have a beta minus decay, and that's when a neutron turns into a proton and it releases this electron or this beta minus decay. So what's going to happen is you're going to see this trend happening where alpha particles are going to be losing 4 of its atomic mass. For example, thorium is going to turn into radium and it's going to lose 4 of its mass because the atomic mass of protons and neutrons weigh the same, and it's losing 2 protons and 2 neutrons. Okay, and because it loses 2 protons, it's now turning into a new element. Okay, so now radium is 2 away essentially from thorium, because thorium has an atomic number of 90, and radium is 88. So it loses 2 protons and 4 of its mass. Okay, because we have to include those 2 neutrons. But then beta minus decays occur where we're having a neutron turn into a proton. So then it's going to gain a proton and it's going to lose a neutron. But if you notice, it says 228, and this actinium is also 228. But because neutrons and protons weigh the same, our mass will stay the same. Okay. But our atomic number will increase by 1. So instead of being 88, it's now 89. So it's back up to actinium. And then it's going to do another beta minus decay, and it's going to turn into thorium again, but it's another isotope of thorium. Okay, so this thorium had 4 more neutrons than this one does. Okay, so it's recognizing these trends of alpha and beta decays. And as we work our way through this list, there'll be a series of alpha decays and then more beta minus decays. But eventually, these decays will lead to something stable that won't break down over time. Okay, let's make I almost want to make an emphasis on radon. So radon is a gas that's usually tested in homes and particularly in basements. And if you read right here, it actually kind of goes through it. It has a half-life of about 56 seconds. Okay, that means it's for about a minute, can travel through the air and lodge in your lungs where it will decay several times. So if you look here in this chain, radon is right in the middle of this chain occurring. And if you breathe in this radon, it's going to emit alpha particles and beta particles inside of you. So the idea is we should not be breathing in this gas because it's basically radioactive. It's going to be giving off these particles. So keep that in mind next time you hear about someone wanting to test radon. Okay, it's kind of a heavier gas. Is because if it does, you happen to breathe it in during this short half-life, you're going to be continuing to have it break down in your system over time. Okay. Thanks for watching. Till next time.